answers to these already. I'm going to walk through them. For number 1, you needed to solve this, distribute the one side, and then get all of your variables to one side, all of your constants to the other. How you did that once you got to this step, if yours wasn't the same as mine, don't erase, because there were 4 different ways to do it. As long as you somehow got your variables on one side and your constants to the other, and then divided and got -6. Questions about that one? For number 2, you may have had to think about this one a lot to remember what it means to be a function. If you have repeating x values that go to 2 different y values, it is not a function, so this one is not a function. Number 3 asks you to translate this. So 3 times the difference, 3 would need to be multiplied to everything. 3 times x minus 7, and then equals 18. Do we have questions on those 3? The last 2. One was a word problem, and there was a lot, so I'm going to kind of talk through each of the steps. First, I underlined anything that was important, so the fact that the Buffalo Bills scored 24 more than twice the number, all of that was important. The fact that it says altogether they scored 66 points, that is important. And then we need to know how many points did each team score individually. So we don't know 2 things. How many points did the Buffalo Bills score and how many points did the Miami Dolphins score? So I labeled both of those, defined both of those. And then because this first sentence told us they scored 24 or more than twice the number of Miami Dolphins, that would be this equation right here. The second sentence told us together they scored 66 points, so that would be like taking whatever they scored, adding them together and get 66. We don't know what those are yet, so we can't actually find those answers. So the second part of that where I have answers in there, disregard that for right now. But we do know that this equation equals the amount of points Buffalo Bills scored. So we could put this in for B, which is what is happening here. And then solve for M. And then we would solve this for M just like we would a normal problem. Combine your like terms, get M by itself. And at the end, we find that Miami Dolphins scored 14 points. After we find that amount, you can do one of 2 things. Either put 14 back in this equation and solve for B, or put 14 back in this equation and solve for B. Either way, you get 52 points. So 52 points and 14 points were our 2 answers for that one. Do we have any questions on that one? I'm just going to slide this up some, or down to For number 5, you needed to solve this equation, and it was a proportion. 2 fractions that equal another, so you had to cross multiply. After you cross multiply, the format was like a regular equation. You needed to distribute, get all of your variables to one side, your constants to the other, and solve. And you should have gotten x equals -9. anyone have any questions on that one?
What would you do for number 3?
For number which one? 3, and then in parentheses, x minus 7 equals 18. Any other questions on those? Remember to keep trying those anytime I give you those, because it is good practice for different review. Really, because unless you're a senior and took your SOL 3 years ago, many of you did not take your SOL last year unless you opted in. So many of you will be taking an SOL this year if you did not opt in, or if you opted out, there we go. And most likely you'll be taking the algebra one, which is stuff we've been doing, review stuff we've been doing. But just keep that in mind, that these are good practices for that. Everyone got a new course calendar. Look at that really fast. As you know, No School November is upon us, so our dates are all over the place. Look at your due dates. They are on Canvas. That way you know kind of ahead of time what is due and when. I've also put on the board when your quiz and test will be, as well as from the paper. So my plan is to finish this next unit right before Thanksgiving break. That way we don't have to worry about it afterwards and trying to remember that stuff when we come back. I have no idea what I have planned for you guys the week of Thanksgiving break because I won't be here. If you happen to be going on vacation, like right at the end of that last week before Thanksgiving break, and you happen to miss your test, you'll just take it when you come back. Questions on the course calendar? We will actually start next when we get back. I just want to talk about our next unit. Our next unit is on systems. So again, that may be review for you, it may not be. And systems of equations is more than one. So we're going to be solving more than one equation. All right, before we actually get into the actual doing this process, solving process, we need to go over a couple things, being this first page. So one, a system of equations is multiple, more than one. I think if you go into Algebra 2, at some point you deal with a system of 3 equations, I believe. But we're just going to focus on 2. And usually when we do this or solve this, we're trying to get a solution. In this case, we're given the solution. And we have to see if this is actually a solution or not. So if we were given like a regular equation and a solution, we would have to put it back in and see if it works. We're going to do the same thing for this one. But when we do this, we have to put this into both. If it works for both, then it is a solution for the entire system. If it only works for one or doesn't work at all, then it is not a solution for the entire system.
Came over my nerves. That was rolling.
Sorry. No, you're fine.
This mark time is great.
So we will put these two numbers into x and y. So I'll do the first one first. So 2 equals negative 1/3. Our x is 3 plus 3. We would simplify this side. 3 times 1/3 would just be 1. Sorry, this should be negative 1. I forgot the negative. And negative 1 plus 3 is positive 2, so I can say that one works. But I can't assume it works for the other one or that it's a solution for the whole thing. I have to still put it in. Yes, smarter. How do you do what? I'm sorry.
What are you trying to find again?
If this works for both of these. So if we get this at the end, then it works. But if we get this for both of them at the end, then it's a solution to this system. We'll see an example where it doesn't work, and it'll make a little bit more sense. So I would put this back in for x and y here. So 2 equals 2 times 3 minus 4. And simplify, this would become 6 minus 4, and 6 minus 4 is 2. So I can say this works. This works for both of these equations, so this is a solution for the entire system.
Just maybe you said, I apologize for being late. I got caught in the rain, literally. Again, solution. You got these are lines again, right, guys? Lines. So you're looking to see are they or do they never touch?
Yeah, we haven't gotten that far.
You already got to that?
We haven't gotten that far
Okay.
yet.
Well, the solution then, all I'm saying is where they meet. It's like, do they get married or not? That's the solution. Where they meet, they're getting married. If they don't meet, they're not getting married, and they're not a solution. And hopefully they stay together. But where they meet is the solution, where they cross.
Do we have questions on that one before we try number 2? We're going to do the same thing for number 2. Put this x and y in to both of these and see does this work or does this not. So for this first one, this would be negative 10 equals negative 3 times 2. If I keep simplifying, this would be negative 10 equals negative 6 minus 4. And negative 6 minus 4 does equal 10, so I can say that one works. And then we can try the other one. Put that order pair back into the second equation. Negative 10 equals 4 times 2 plus 3. This would become 8 plus 3, which is 11, which would not equal or not work. So because one of these does not work, this could not be the solution to the system. So that would be a way to check yourself when we actually get into how we actually solve this. To put it back in to both and see, do both work? If you have any questions on those two, I'm going to give you the next 5 minutes. It may not take you that long to do 3 and 4, and then we'll come back and we'll talk about it. To check your answers, number 3 should have been no. When you put it in, it only worked for one of them, not both. And 4 should have been yes, it did work for both. So 4 would be a solution, 3 would not. Questions on those two? For the bottom 4 questions, so this was we were given a solution and how to make sure it worked. The bottom 4 are given graphs and we have to find the solution, and then we'll actually be given equations and have to find the solution, graph and find the solution. So for these bottom 4, anytime these 2 lines cross, They will intersect at some point. That point will be some solution, like we were just given, some ordered pair, that we check to see if those work. If these cross, that is your solution. Now, when we get into the graphing piece, how you graph may affect where they cross. So there's that issue. But if they cross at a point, this point would be the solution for the system of equations. So you would write -2, -1. And you would do that for all of these. So number 6 crosses at this point right here. So your solution would be -1, -1. What would your solution for number 7 be? 3, -1. Be careful with your counting. And with the graphs, look at your graph because it'll look closer and better counting wise than trying to find mine. And then for number 8, I heard like sort of -4, -2. -4, -2. Okay, so on the very back of that page are graphing examples. It also has like a little picture of what types of solutions there are, but it's kind of small. So skip to the next page, that way we can see them a little bit bigger. A page that looks like this. I'm going to pull this down so you can write these or those 2 parts. So as I mentioned earlier, a system of equations are 2 or more equations with the same variables. Graphically, the point the solution to a system graphically is the point xy where the 2 lines intersect. So we just saw that on those 4 graphs. Wherever they intersected was that solution point. Algebraically, it's the point xy that makes both equations true. So that's what we did first. See, did it work for both?
I know, I want to hear the story. Dang it, what the hell? Oh, you're so smiling. And the joke.
Don't really care. And I also didn't want him to say something that I'd have to hear about later. I'm sorry, does anyone still need that?
I'm sorry. Wait, someone's speaking 1 more second.
Yeah. For this next part, we're going to draw in 3 different types of solutions, just like randomly. I would say if you have like a pencil and a pen, you can use that. Or if you have like colored pencils or different colored pens, I would get those out. If you want to use like a highlighter, I have some. I do have some red and blue and black pens as well. It's just easier to see 2 different lines with 2 different types of ink or colors. So for each of these, draw some random graph x and y axis. And then there are 3 types of solutions. These are the same type of solutions you would get if you were just solving a regular equation. 1, none, and infinitely many. If you have some set of intersecting lines, I'm just going to draw 2 random lines that cross each other. Whatever point they cross at, that would give you 1 solution, and you have an ordered pair at that crossing point, at that intersection point. You could have parallel lines, and we just finished our unit on parallel lines. What do we remember about lines that are parallel? Shikai, say that one more time. They have the same slope. What else do we know about parallel lines? They never intersect. So draw 2 random lines that will not intersect. My slope kind of looks off like they're not the same, but they're supposed to be the same. So if these parallel lines never intersect, they will never have a solution. So you can put an S or a 0 with a line through it. And then the last type of solution, the infinitely many, is if we have 1 line, and then we have another drawn literally on top of it. That would mean it has the same slope and the same y-intercept, so it's the exact same line. If you had a case like that, it would cross at every single point along the line. So this would be an infinitely many solution. So you can put IMS or infinity sign. Mine did not look like one, but that's okay. So these will be the different types of solutions you can have. 1, none, or infinitely many. Questions on the types of solutions? I'm going to pull up the steps for this. So to solve a system of equations by graphing, we're going to first rewrite the equations in slope-intercept form if they're not already. So if they're in slope-intercept form, we can skip that step. 2, graph, this should really say the lines, because there's 2 of them. So we're going to graph both of the lines on our graph. After we have graphed both lines, we should be able to see what type of solution it has. 1, none, or infinitely many. Great, so we're going to do a few of these together, then I'll let you practice them. Anyone still writing down this part? So we're going to start with number 1. Both of these lines are in slope-intercept form, so we don't have to do anything to them. This is definitely where I would say try graphing one in one color, one in another. That way you can visibly see if they intersect, if they don't. I can look at these 2 and say that these 2 have different slopes. So they don't have the same slope, so they can't be parallel. They don't have the same slope and y-intercept, so they can't be infinitely many. So this is going to have one solution. I just don't know what that solution is. So I'm going to graph these in two different colors. When you do this, make sure your graph extends all the way across. If you need or want a ruler, right next to Mr. Northrop, there's a colorful cart. There are rulers right there. Feel free to grab one. But make sure your graphs are very accurate, because if you move it off to the side, it may cross at a point that it's not supposed to cross at. So for number 1, our y-intercept is at -8, so we would start there. Our slope for that first one is +1. So we would go up 1, right 1, as many times as possible, and fill up your graph. And then go back to your y-intercept and go down 1, left 1, as many times as possible, and fill up your graph that way. Once you have all of your points, go ahead and make a line to connect your dots. And then you're going to do the same thing for the other one. So this one has a y-intercept of +1 and a slope of -2. So I can go up 2 and left 1 as many times as possible. Do that, fill up your graph. And then go back to your y-intercept and go down 2, right 1 as many times as possible, and fill up your graph. At some point, you'll see that they intersect. Still make sure that your graph is filled with all of your slope points, and then you can draw your line. We see that these two lines intersect. We knew it was going to have one solution anyway. Wherever those two lines cross, if it helps you see it a little bit better, you can circle it. And then write that solution. So that would be 3, 5. 3, -5. If we were to put that back into both the first and the second equations, we would find it to be true. Do we have any questions on that one? Yes, Marta. Sorry, say that one more time.
I didn't get it. I'm not sure where it got it.
Mr. Northrop, can you look at hers to see where it is? We're going to skip number 2 and move on to number 4. With number 4, one of the equations is not in slope-intercept form, so we'll have to solve that one before we do anything else. So we would need to subtract x. I'm going to go ahead and switch these, so it's -x plus 4. And then divide everything by 2. So that new equation would be y equals, this is really negative 1x, so this would be negative 1/2 x plus 2. And then I could graph that one. I'm sorry, before we do that. When we look at these two equations, they have the same slope and the same y-intercept. What type of solution will that give us? Infinitely many. So I could put that already, because I know that's what I'm going to get. But I still have to graph it, because I'm solving this system by graphing, even if you know the answer already. So for this one, because it's the same line, I would say graph it once. So start at +2, and then I'm going up 1, left 2 as many times as possible. And then going back and going down 1 and right 2 as many times as possible. And drawing my line there. That was not straight. And then if you have a highlighter, you can just highlight over top of it, or if you only have a pencil or a pen or something like that, what you can do is extend your line and draw another arrow over top of it. So if you do it that way, maybe draw the arrows differently, like one with 2 arrowheads or something like that. That way I know that both lines are still technically there.
Just I don't want to do walk noise. That's the noise I make when I don't want to do walk.
Or if you have a highlighter, you can just highlight over all of it and draw the arrows again. Either or. Just somehow I need to see that there are 2 lines there and not just one. Do we have any questions on that one? We're going to do number 6. For number 6, there's another equation we need to solve. So let's do that before anything else.
What? Wait, oh no, I did a big stupid. Oh my gosh.
It's okay, just change the numbers.
Okay.
Subtract x on both sides. So you have negative y equals negative x plus 2. Divide everything by negative 1. So you get y equals a positive x minus 2. When I look at this equation and the first one, these have the same slope but different y-intercepts. What type of solution would this be? Say that again. Parallel? No. Because these would be parallel lines. So even though we know that, we still have to draw them. So I'm going to draw this one first, starting at negative 2, and my slope is positive 1, so up 1, over 1, as many times as possible. Fill up your graph. And then down 1, left 1, as many times as possible. Fill up your graph. then draw your other one. This one is going to start at +5. The slope is the same, so we're going to go up 1, right 1, as many times as possible, and down 1, left 1, as many times as possible. And draw your line. I'm sure it'll be an interesting journey. So they kind of look like they're going to intersect like off the graph, but they shouldn't. Do you have any questions on that one? The last one we're going to do is number 8. One of these is one of those special case equations where it's going to be a horizontal or vertical line. The other one we need to solve, so I'm going to go ahead and do that one first. Subtract 3x on both sides. So we have negative 2y equals negative 3x minus 18. Divide everything by negative 2. So your equation would be y equals positive 3 over 2x plus 9. I think these graphs are a 10 by 10, so the 9 will fit. So we're going to start at positive 9. And because we cannot go up 3 and right 2, we'd be off the graph. We're going to go down 3 and left 2 as many times as possible. And draw that line. When you get an equation, does an x equals or a y equals, it may help you if you rewrite your formulas. So if we have an x equals, is this going to be a horizontal or vertical line? Vertical. So at negative 2, this is going to be a vertical line straight up and down. That bothers me so much. We didn't do this at the start, but these two lines did not have the same slope. So they weren't going to be parallel. They didn't have the same slope and y-intercept, so they weren't going to be just one line. So these were going to have one solution. What is that solution? That sounds right. 1, 2, 3, 4, 5. I think mine is at 6. So I say just double check that, but. So the hardest part about solving systems by graphing is, 1, making sure your graphs are correctly drawn, that you don't mess up your slope, and 2, knowing what type of solution you have. There are 3 different types of ways to solve systems. This is just one. This, I feel, is the easier of the 3. because you're not really solving a whole bunch of things, you're really just graphing. Do we have any questions on solving systems by graphing? For the remainder of class, you have, what was it, 4 problems? 1, 2, 3 on this page. There was 1 on here, as well as we skipped the ones that had these 4. You can work through any of those. If you feel good about this and don't feel like you need to continue that practice, you can work through, there are 2 Khan Academies that are due today on solving systems by graphing. 1 Delta Math that is due next time I see you, which is next Friday. So you can work through those, you can work through this practice, but everyone has something to be working on. Anyone have questions on what we're doing for the rest of class? Okay. You now have the same to work after Mr. Northrop says.
I just want to ask you a question. Which one of these is in slope intercept form? Just a quick review.